Hello friends, welcome to our channel Piping Mantra. Today we are going to study pipe rack piping and its consideration. A pipe rack is a main artery of process unit connecting several services. Pipe rack are structures designed and built specifically to support multiple pipes where adequate structure is not available. It connects all equipment with lines that cannot run through adjacent area because it is located in the middle of the most of the plant. The pipe rack must be erected first before it becomes obstructed by row of equipment. Normally, the pipe rack with its structure and platform requirements is the first priority item for detail engineering of process unit. Normally, when process building is on its 30% phase. Pipe rack carry process piping, utility piping and also include instrument and cable trays as well as equipment mounted over all of these like we can see in the picture. The exact width of pipe rack, number of level and elevation of level, access and maintenance platform are finalized during pipe rack piping study. Pipe rack general arrangement is finalized during the development of overall plot plan. Some input data and drawings are required to be studied before starting the detailed design of pipe rack, like unit plot plan or overall plot plan, piping flow diagram and PNID, plant layout specification, client specification, material of construction, fireproofing requirement, and statutory requirement. There are various shapes of pipe rack available like L shape, I shape, T shape. These shapes shall be considered based on area available. Like this, one side we have dead end and pipe can run in one direction. And in this, line can be run in two directions. And this line can be run in different direction like northeast or southwest. And this line can be enter or exit from three different sides. In U-shape, line can be run in four directions in all sides. This is combination of T-shape and I-shape. This is the most common one and the complex one, which is used in very large chemical plant. Pipeline in the pipe rack are classified as process lines, utility lines, and relief header lines. Process lines are those which interconnect nozzles on process equipment more than 20 feet apart. Closer process equipment can be directly interconnect with pipelines. Product lines which run from vessels, exchangers or more often from pump to the limit of unit storage or header arrangement outside the plant. Crude or other charge lines which enter the unit and usually run in the rack before connecting the exchangers, furnace or other process equipment like holding drum or booster pumps. Utility lines in the pipe rack can be put in two groups. Like in group 1, utility headers serving equipment in the whole plant. Such lines are low and high pressure steam line, steam condensate line, plant air line, instrument air line. If required, cooling water supply return line and service water can also be arranged on the pipe rack. The second group is utility lines serving individually one or two equipment item or a group of a similar equipment like furnace and compressor in the plant. Such lines are boiler feed water, smoothing steam, compressor starting air, various fuel oil, lubricating oil, cooling oil, fuel gas, inert gas and chemical treating lines. Relief line header. Individual relief line, blowdown line and flare line should be self-draining from all relief valve outlet to knockout drum, flare stack or to the point at the plant limit. This line, which must not be pocketed up since it is associated with relief valve, a pocket in a relief line is more expensive because usually an extra condensate pot is required with instrument, valves and pump. To eliminate pockets, some relief line header must be placed at the higher elevation. Connecting into the header can be laterally 45 degrees if pressure drop is critical within the system. Relief header line should have a slope of 1:200 in a direction of the discharge. It will be located at the edge of the rack to accommodate any flat expansion loop requirement that its length and temperature. Instrument lines and cable trays are often supported in the rack and extra space should be provided for these facilities. The best cable tray arrangement eliminates almost all elevation changes between the plant and the control room. This can be easily achieved when cable tray is supported outside the pipe rack column on a suitable elevation. But at the same time, we have to maintain safe distance between hot lines and trays. Let's see what are the steps required in pipe rack piping. The very first step in development of any pipe rack is generation of line routing diagram. A line routing diagram is a schematic representation of all process piping system drawn on a copy of pipe rack general arrangement drawing or on a unit plot plan, where the pipe rack run in the middle of the process unit. based on required information available. Once the routing diagram is completed, the development of pipe rack width, structure column spacing, road crossing span, number of level and their elevation should be started. The pipe rack width can now be worked out with the typical cross section of the rack with the levels. Pipe rack width can be calculated with this formula, where F is factor of safety. If we are counting line from the piping flow diagram, we have to consider it 1.5, and if we are considering line from PNID, we have to take it as 1.2, and N is the number of line in densest area up to 450 NB size, and S is 300 mm average spacing for line size bigger than 250 mm. However, for the line size which are less than 250 NB, we have to consider 225 mm spacing. A is the additional width, larger line more than 450 NB or for electrical and instrument cable trays. And B is the future provision. The total width of the pipe rack shall include 20% extra space for future expansion, modification in the unit for rack width up to 16 meter and 10% of the rack width above 16 meter. The future space percentage is normally based on client requirement. The width of the rack shall be 6 meter, 8 meter or 10 meter for single base, and for double base it would be 12 meter, 16 meter and 20 meter, which is having 4 tier maximum. The spacing between pipe rack portals shall be taken as 6 meter in general. However, it can be increased to 8 meter depending upon the size of the pump to be housed below the pipe rack. So guys, that is a wrap up for part 1. We are going to continue this topic in part 2. Please do watch. So guys, please do like, share, comment, subscribe to our channel and follow us on Twitter and LinkedIn. And if you want us to prepare a video on some certain topic, let us know in the comment section. And please don't forget to press the bell icon to get the all notification. Thank you.